Good morning, everyone. Okay, so today we're going to be looking at Lesson 93. The title of the lesson is Two-Step Equations and Inequalities. This is kind of a fun lesson. This is really a little bit more about algebra, and I think that you could really enjoy this. So let's go ahead and get started. It's on page 633 in your books if you want to turn there. Please feel free to do so. Okay, so we have already been solving one-step balanced equations. We've been doing that for a little while now. So today we're going to actually increase this to a two-step balanced equation is what they call it. I'm going to try to give you a little artwork here. We've talked about this before where you can see like a scale. I'm going to scooch down, turn my pencil on. I'm going to scooch down here at the bottom of my document. You don't need to take these notes down here. You can just kind of watch. But here's my scale. You know, it looks something like this. And then it has like a little tray here, and a tray here. And you know, it's got this thing here. It's like the scales of justice. I don't know, that looks like kind of like a scary little figure there. But let's just say that we have an equation that looks like this. 2x plus 5 equals 35. Okay, this is a two-step equation. We've been looking at problems that might be like x plus 5 equals 35. And you know that we would subtract 5 from both sides, right? That's a one step. And then we can figure out what x is equal to by that one step, right? But here, we actually have two steps in our problem here. I've got 2 and x are being multiplied, and then I have an addition of 5. So this is a two-step balanced equation that we're going to be working with. If I were to lay these things on a scale to show the balance of that, I would have something that weighs 35 pounds over here, maybe a big block. And on this side, it's saying that I have a block that weighs X amount of weight and another X that weighs another amount of weight, and then a 5 maybe pound or whatever, 5-pound block, okay? But those are balanced. This is what this is saying. I have two X's and a 5 that are supposed to be balanced to 35. So here's my two X's and my 5 and my balance of 35. Okay, that's basically what we're trying to figure out are what is each X going to be, what is X going to equal to make this thing balanced? So the first thing that we want to do is keep the thought in mind that we want to isolate the variable, just like we did in a one-step balanced equation. But in this case, there's two things to undo. Normally, we just undid the addition of 5 by subtracting that. Well, we still want to do that. So let's go ahead, and that's the first step we would make here. I always like to put a line under it to kind of do my math. We have our 2x remaining, and then 35 minus 5 is actually 30. So here I am back to an equation that has just one step left to do to solve this. So 2 is being multiplied with x. So in order to undo the multiplication of 2, we would divide by 2. Remember, we use the inverse or opposite operation. Then we can cancel our 2's because 2 divided by 2 is 1. That gives me my x variable alone. And 30 divided by 2 is 15. So that's saying that each one of these blocks up here is 15. Well, would that be true? 15 plus 15 is 30. Plus 5 is 35. So it does seem to check out. So how do we check that? It's a good idea to check it to make sure that you actually have arrived at the right answer. So I'm going to rewrite the problem down here, and I'm going to substitute now in for x. I'm going to put the 15 that I said that x is actually, that's the value of it. Does that actually equal 35? Yes, it does. So it does check out. Okay, now that's just to kind of introduce you to what we're going to be doing today. So we have two steps that we're doing. We're going to be subtracting one of the operations here, and then we're going to be taking care of the other operation as well. So let's go on up to our notes now. We'll look at the first problem. Example 1 is 0.4x plus 1.2 equals 6. Okay, so if we follow the method that we just did below together, or that I showed you, we would now subtract 1.2 from both sides. Now remember, this is a whole number up here, so I'm going to just put a 0.0 there, so when I do my subtraction, I have my decimal point in the correct spot. So I bring down what is left, and I do the math here, I'm going to end up with 4.8. Okay, and then I'm going to divide both sides by 0.4 because that's what I do to isolate my variable of x. It's being multiplied here, right? That's being multiplied, so I divide it in order to undo it. That's not new to you. That's something you've been doing. Okay, so that gives me 1x or just x. And I'm going to give you a gift here today. Well, actually, you know what? I'm not, and let me tell you why. Because we're going to be dividing with a decimal. So I'm just going to kind of go over to the side here and write this out. 4.8 divided by 0.4, or 0.4 if you like the 0 there. Okay, remember our divisor cannot have a decimal there, so we have to move that over to the right one spot, which means I have to move it over to the right one spot here. So my new problem is actually 48 divided by 4. I'm going to go ahead and put my new decimal point up here. So my answer is going to end up being 12. X equals 12. Now I'm going to check that because that would be the smart thing to do. So how do I check it? I'm going to put my original equation here. And we're going to substitute in what we said x is equal to. Hopefully it will in fact work out. So we're going to do 0.4 times, oops, that's a little messy. 0.4 times x, which is 12 is the value we said over here. Oh dear. Plus 1.2 equals 6. Okay, so if you multiply 12 times 0.4, you're going to get 4.8 plus 1.2. And does that equal 6? Let's see. 2 plus 8 is 10. Carry the 1, 4, 5, 6. And our decimal point would be right there. So yes, that actually does check out. So x equals 12 is the correct answer there. Let's move on over to example 2. Now this one looks exactly the same. The only difference is instead of adding like we did over here, this was an addition, we're actually going to be subtracting here, okay? But we still deal with that being our first step. All right, so let's go ahead and take care of this problem. So I'm going to actually, I have to undo the subtraction of 1/2. So I use the opposite operation, and I'm going to add 1/2 to both sides. Right? So this is going to cancel each other out. A negative 1/2 plus a 1/2 is actually 0. I'm going to bring down what's left on this side, which is negative 2/3 x equals, I hope I have room to finish this problem up here, equals, I have to get common denominators here, so I'm going to go ahead and do that. Common denominator should be 6, right? How did I get that? I multiplied by 2 here, so I get 2/6. I multiplied by 3 here, so I get 3/6. And we're adding, remember? We're adding. That's what happened when we moved the 1/2 over here. So now I have 2/6 plus 3/6. I get 5/6 here. Okay, but I'm not done yet, right? Because I have not isolated my variable. I don't know what x is equal to. So I have to take care of isolating the variable. So I have on the left-hand side here negative 2/3 times x. Now remember, yes, I could divide by a negative 2/3 to get 1x, but remember when we see a fraction over here with the variable, I can use the reciprocal. Remember, we're just looking for a way to make this 1x. So if I multiply by a negative 3/2, that's going to help me, that's going to give me a positive 6x over here, right? Excuse me, positive 1x, because I'm going to have 6/6, right? Negative 3/2 times negative 2/3 is 6/6, which is 1. So we've canceled that out. Notice that I used the negative sign to multiply with so that I could get a positive result here. Okay, we have to do the same thing to this side. So we're going to multiply with a negative 3 halves. And we're going to end up with a negative 15 over 12. Oh, you know what? I'm going to back up because I can actually cross cancel here. Where can I cross cancel? Right here. How many 3s? 3 is going to become a 1, and 6 is going to become a 2. So I'm going to have a negative, right, because I have a positive times a negative. 5 times 1 is 5, and 2 times 2 is 4. And that is the answer to that problem, negative 5/4. You could say it's negative 1 1/4 if you want to do that, but negative 5/4 certainly does work out to be correct as well. Okay, let's move right along. We'll do another one here. Now, example 3, they just have it flip-flopped. So instead of having the x term on the left-hand side of the equal sign, they put it on the right-hand side. Not a problem. We're going to work it out the same way. If you don't like it that way, you can rewrite it like this so that your x term is on the left-hand side. But I'm going to work it out the way that it is. But if you want to do it this way, you certainly can. Okay, so in my mind, I think I'm trying to isolate the variable. Right now, the addition of 6 is in the way, so we're going to subtract 6 from both sides. It's going to zero out here. I have 3x left over on this right-hand side of my equal sign. And I have a negative 15 minus 6. That's going to give me a negative 21. I'm still working towards isolating the variable. So I'm going to divide both sides by 3. That'll give me a 1x. And negative 21 divided by 3 is a negative 7. And that is my answer. Not too bad, huh? All right, now, example 4 is slightly a different problem. We're actually talking about an inequality here because I have a greater than or equal to sign in there. And so it's not 2x minus 5 equals 1. It's 2x minus 5 is greater than or equal to 1. So we're going to work a few steps in this. We're going to actually try to figure out what numbers could represent x, and we're going to plot those on the number line below. So let's see here what we need to do. Okay, so, sorry, I had to look at my notes here really quickly. All right, we're going to handle this just like we did the previous 3 problems. Okay, so in your mind, you can think about this still, you can think about this sign as though it was an equal sign. It's not, though, but I say that because I want you just to solve the problem the same way we did the other 3. Okay, so what did I do on the other problems? If this was an equal sign, remember we added 5 to both sides. That would take care of the 5. I have a 2x left, and it's greater than or equal to 6. Okay, I'm not actually changing it to equals. I'm just asking you to think of it that way in your mind for a moment. Okay, so now I have 2x is greater than or equal to 6. We continue on with the problem just as we did when it was an equal sign. In order to isolate the variable, that is our goal in algebra. I'm going to divide both sides by 2. That's going to take care of this on the left-hand side. That does isolate my variable. So I have x is greater than or equal to 3. Now you guys have seen something that looks like that. I'm going to check it, and I want you to do the same, and I want you to see, I'm going to pick a couple different numbers. Okay, so this isn't x is just equal to 3. It is equal to 3, but it's also, it can include a number that's greater than 3. So we're going to try a couple different numbers to check our solution. So I'm going to put a line right here because we're going to try 2 different things. All right, so the first thing I'm going to try is I'm going to use the 3. I'm going to go back. Remember, we always start with the original equation. And I'm going to stick in there 3 because x can be equal to 3 according to what we figured out over here, right? X can be 3, so I'm going to stick a 3 in there and test it. I get 6 minus 5, which is actually 1. Okay, so in this case, 1 equals 1, right? If I look at that part of my inequality sign, that checks out. Okay, let's try a 4 in there. Because my x over here says x can be greater than 3 as well. It can be equal to 3. That's why I wanted to use 3 in the first check method. And on the second one, we're going to use something that's greater than 3 because my solution says that x can be greater than 3. So let's just plot a 4 in there. 2 times 4, let's see, let me write up here, 2x minus 5, so I don't lose sight of the original equation. Let's see how that pans out. So when I put in a 4, I end up with 3 is greater than or equal to, in this case, it's this part of it, it's greater than 1, right? 3 is greater than 1, so this checks out too. Okay, so we did solve it correctly. So what I want us to do now is I want us to plot this. Just draw some lines on your number line down here. We're going to graph this, and I'm going to just start with, let's see, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, let's just start at like -1, 0, 1, 2, 3, 4, 5. I'm going to stick a 6 on there too, just because the notes you're going to see on Edmodo will have those on it. Okay, so let's plot it. So x is greater than or equal to 3. So we're going to go to 3 and draw our circle. Now, it's going to be greater than or equal to. So what would we do? Would we leave the circle open or would we close it? It's equal to 3. Can be equal to 3. So we're going to close the circle, and it's greater than. So make sure you make kind of a nice bold line. Don't do a scribble mark. Just do a nice bold line and a new arrowhead indicating you're heading in that direction forever and ever. Okay, and that is how you solve that problem. And that, I'm just looking to see if I've covered all the notes, and we have. That concludes the lesson today. So I hope you enjoyed that. Two-step, this is moving forward and learning some skills for algebra. Doing a two-step balanced problem is kind of exciting. We're getting where we're going to be seeing a lot more. And so I think that's fun. All right, guys, so thank you for watching, and I will see you on Zoom.